Hello YouTube, this is a project video for the CS51 2014 final project. Our project is entitled Dijkstra's Algorithm on a Graph of Wikipedia Pages, and our team members are Daniel Leichus, Jason Shen, and Jane Chen. We were curious about finding the shortest path between two given Wikipedia articles, so we decided to use Dijkstra's algorithm, where nodes are Wikipedia page titles and edges are the links between Wikipedia pages. In our creation of the graph, we gave each edge a weight of 1, so our algorithm runs like a breadth-first search. But our algorithm implementation does not necessitate this and accepts edge weights of any integer. To create our graph of Wikipedia pages, we use the map.make functor in the OCaml core.standard library. This created a dictionary with key-value pairs. Our keys were the Wikipedia page titles. Our values were basically a list of pages with corresponding edge weights. Dijkstra's algorithm requires a priority queue, which we implemented using an imperative binary min heap. This min heap used a splay tree, which means recently accessed elements are easy to access again. Code was inspired by code from Simon Cruanes on GitHub found at the link here and also down below in the description. We also used the map.make functor to create a lookup table that for each page stores the current guess of distance to the starting node, the current guess of the previous node, and whether the page has been pulled from the queue or visited yet. To construct the graph, we got database dumps of Simple English Wikipedia, which is a wiki about 1/50th the size of Wikipedia, written using simple English words. However, there are still around 100,000 articles and 5.4 million links, so this was no small project. We used SQL queries to clean and format the database into a text file, and then the core.standard module in_channel to read in the text file into our graph. We implemented Dijkstra's algorithm in a pretty standard way except for one slight change. What if we wanted to find a path from a node to itself? This is explained in the documentation. We run our program in the appliance terminal. As arguments, we pass in the titles of the pages between which we want to find the shortest path. It will output both the length of the shortest path and the path. As you can see, there are 3 links required to get from Jesus to Hitler, and the path is Jesus to Rome to Greece to Hitler. We are extremely satisfied with our project, but if we were to make one improvement, it would be to save the graph so this same graph can be used in multiple calls to Dijkstra's algorithm. Currently, the exact same graph is being constructed each time Dijkstra's.native is being run. By getting rid of this overhead, perhaps we could run our algorithm on a graph of the full English Wikipedia in a short amount of time, after the full English Wikipedia is read into a graph, of course. Another thing we would want to work on is the issue with redirects. For example, Hitler redirects to Adolf Hitler, which links to Germany. Our implementation counts this as 2 links, whereas others may consider it 1 link. We would like to thank Simon Cruanes, from whose code inspired our imperative binary min heap, Joshua Lee, our CS51 final project TF, and the entire CS51 staff. Thanks for watching.